Alright, here is the Unit 6 review. Uh, for the first question, it says here, simplify the following expression. So basically here, we are adding a fraction to a fraction. And to do that, you need to have a common denominator. So there's two ways you can do it. One way is by Desmos, and the other way is just to do it by hand. I'm going to first show you how to do this by hand, and then I'll show you how you can check your answer or answer choices in Desmos to see which one works. Alright, so when we are adding fractions, you need to have a common denominator. So to get a common denominator, we need to first factor the denominators to see it in factored form. So remember that when it's in factored form, you have it written in parentheses. That's the quickest way to see if it's in factored form. So this right here is not. So let's factor this. So to factor this, I'm going to bring the numerator down, x minus 4, and then denominator, I'm going to write it in factored form, x. And so here we need to think about two numbers that multiply together that give you -3. That have a positive and a negative give you -3. And then when these same numbers have to add up to +2. So that would be 3 and 1. Because 3 times -1 is -3. 3 plus or minus 1. 3 minus 1 is 2. So that works. Okay. So this is something that we did in Unit 2, where we factored trinomials. Alright, so now let's do the next rational expression. So I'm going to bring the numerator down, and then the denominator, I'm going to factor this. This is factoring using perfect squares. It's called differences of squares. So here you put x, and then since 9 is a perfect square, because square root of 9 is 3, we can do plus 3 and then minus 3. Okay, so for this one, we did this in Unit 2. It's called differences of squares. Alright, so now let's see how to find a common denominator. So you notice that there's an x plus 3 here and an x plus 3. This one has an x minus 1. This one does not have an x minus 1. So we're just going to do x minus 1 here. And then you're going to multiply the numerator also by x minus 1, x minus 1, x minus 1. And the right expression has x minus 3. This one does not. So we're going to put x minus 3 here, by multiplying the numerator also by x minus 3. Okay, so now we need to simplify. We need to multiply the numerators here. So we're going to multiply it by foiling it out. So here, I'm going to maybe just to save some space here, let me do the foiling part on a piece of sticky note so that I can remove it. So when we're foiling this part, you do x times x, which is x squared, and then x times -3, which is -3x. And then you have -4 times x, which is -4x, and then -4 times -3 is +12. Then we need to combine these two, -3 plus or -4, negative. Well, negative plus a negative, you still have a negative, and you add them. So 3 plus 4 is 7x plus 12. So this comes out to x squared minus 7x plus 12. So that's what I'm going to write here. X squared minus 7x plus 12. Then I'm going to bring this whole denominator down. Plus, I'm going to do the same thing for the next one as well. I need to multiply it back up. So for the next one here also, I'm going to do x times x is x squared. X times negative 1 is negative 1x, which is just negative x. Negative 3 times x is negative 3x. Negative 3 times negative 1 times negative times a negative is a positive 3. Combine your like terms. So there's a 1 here. So negative 1 plus negative 3, that's negative 4 plus 3. So that's this part over here. So I'm going to write that up over here. X squared minus 4x plus 3. And then now we're going to bring this whole denominator down. Now we have a common denominator, x plus 3, x plus 3, x minus 1, there's an x minus 1, x plus 3, x minus 3, x minus 3. I know this is written like this, but that's okay, they're still the same thing. So now to finish the problem, we need to combine like terms. So we're going to put these two together, so x squared, so this is a 1x squared, right, 1x squared. So 1 plus 1 is 2, x squared. Negative 7 plus negative 4, that is negative 11x. And then 12 plus 3, that is 15. That's in the numerator. And in the denominator, you have all of this. So here you have 2x squared minus 11, yeah? And then the denominator, x plus 3, x minus 3, and then x minus 1. So it is a. Now that's a long process. It took me like, what, 6 minutes to do this? That's okay. I will show you how you can maybe do this, find your answer a lot faster in Desmos. So in Desmos, you're going to type up your original. I already have it typed up here. You're going to plug this in here, and then in the next line, you notice it graphs it for you. In the next line, go ahead and type up your answer choice that you got just to check it. 2x squared minus 11x plus 15 over x plus 3, x minus 3, x minus 1. And look, it's the same exact graph. So that's how you can check it as well. Okay? Alright, problem number 2. So here we want to multiply these two fractions because of the multiplication. So we multiply the numerators, multiply the denominator. But it helps us if we simplify it first. So what you can do here is you can rewrite this expression. This is equal to, so a plus b cubed is the same thing as, I didn't want to write that, sorry. A plus b times a plus b times a plus b. Ignore that part. Over a, 18, times, here you have 2 over, and then a plus b squared is a plus b times a plus b. And then here, what you can do is you can cross out common factors. So you can take out a plus b, a plus b, a plus b, a plus b. And then 2 over 18, you can reduce this because 2 goes into 2 once, 2 goes into 18 9 times. So now we can multiply the numerators. So you have a plus b, let me just write it down here. So you have a plus b over 9 times 1 over, if everything gets cancelled out, which means that there's a 1 here as well, which is equal to just a plus b times 1, that's just a plus b, 9 times 1, that's just 9, and this is my final answer. There is a way you can check your answer in Desmos as well. Let me show you that. So what you can do in Desmos is, again, you can type up the question. So I put my division, a plus b to the power of 3 over 18 times division 2 over a plus b squared. And then here you can press all and then just change this to some number. You can, I like to put decimals. So just slide it, it doesn't matter, whatever, just don't put like negatives, put positives. Okay, and then your calculator will give you this, whatever the answer is, and then in your answer choice, you put in what you got, same thing, a plus b over 9, and notice my answer is the same. If you use the other one, these two answers will be different, so you know that's not the right answer. All right, number C. Number 3, I mean. Okay, which of the expression is equal to this? So basically, again, we're checking. So to find which is equal, I mean, there is a way to do this by hand, but at this time, let me just go ahead and show it to you in Desmos. So in Desmos, what you're going to do is, you can plug in this expression. So I'm going to put 4y squared minus 3y squared over 5y squared. Nothing happens because it's expecting you to graph something. So what I usually do in this case, I just go back and change it to a capital Y. Because whenever you use X and Y, it wants you to graph. So whenever you get the symbol, just go back and change those to capital letters, uppercase, and then press this, and then just change the slider. And then now you're going to plug in your answer choice and see which one gives you 0.2. So I'm going to plug this in. So Y, make sure to use capital again, or else it won't give you calculated for you. See, the decimals didn't match, so it cannot be this one. I'm going to go to answer choice B. So you have 4 over 5, y to the third, plus 3 over 5. Nope, it cannot be this one. Let's look at answer choice C, 5 over 4, y to the power of negative 3, minus 5 over 3. Nope. So it has to be answer choice D, but we'll check it. 4 over 5, y to the third power, minus 3 over 5. Oh, that didn't work either. Then what did I do wrong? Oh, sorry, that was supposed to be a 5. My bad. Oh, well, there you go. That worked out. Okay, so when I changed the question, I accidentally put a 2, but it was a 5. That works. And then answer choice D. See how you get the same answer? Even if I've changed this to different numbers, they always will be the same answer. So that's why it is D. Okay?